Hello, my dear students. Welcome to the lecture on OSI model and TCP/IP protocol suite. I'm here with you, Amit Haldar, Assistant Professor, Department of Tripoli, World University of Bangladesh. So, what is the objective of this lecture? So, our objective is to discuss the idea of multiple layering and also in data communication and networking and the interrelationship between layers. To discuss the OSI model and its layer architecture and to show the interface between the layers, to briefly discuss the functions of each layer in the OSI model, to introduce TCP/IP protocol suite and compare its layers with the ones in the OSI model, to show the functionality of each layer in the TCP/IP protocol with some examples, to discuss the addressing mechanism used in some layers of this TCP/IP protocol suite for delivery of a message from the source to the destination. So first of all, we will go through to the introduction of the OSI model. It's a layered model architecture which has been established before 1990s, and it is known as open system interconnection. But this did not happen till now. But the TCP/IP protocol is commonly used in the internet arena, become the dominant commercial architecture because it was used and tested extensively in the internet. The OSI model was never fully implemented. So, what are the protocol layers? So, a protocol is required when two entities need to communicate. So, it is the important thing that how they could communicate with each other. That means a face-to-face example, that's Maria and Anne are the neighbors. They will show some signs and they will communicate with each other by a language. So, which is the protocol layer? If anybody if anyone living different in another town, how they could really communicate with each other? They could write a letter and post through to a post office, and then the another receiver will get its message. So that is the protocol hierarchy. Here you can see there are different type of layers. That is to reduce their design complexity. Most networks are organized as a stack of layers or levels, each one built upon one the below. The purpose of each layer is to offer certain services. That means there are certain services from the physical medium to the different layers from here to this, and also you can send the same details from the host 1 to host 2 communications. So the purpose of each layer is to offer certain services to the higher layers while shielding to those from the details of how the offered service is actually implemented. The OSI model, this model is based on a proposal developed by the International Standard of Organizations. First of all, you have to know what is ISO. ISO sets the standards. Okay, it's a standardization organization, and OSI is the reference model. It's not a protocol. Okay, it's a reference model, and it was first introduced in the late 1970s. An open system is a set of protocols that allows any two different systems to communicate regardless of their underlying architecture. Now, this purpose of the OSI model is to show how to facilitate communicate between the different systems without requiring changes to the logical and underlying hardware and software. So there are some hardware and software that has been incorporated in the OSI model. The OSI model is not a protocol. It's a model for understanding and designing the network architecture that is flexible, robust, and interoperable. The OSI model is a layered framework for the design of network systems that allows communication between all types of computer systems. This is the basic of the 7 separate but related layers of OSI model. So largely we can divide it on 3 types of layers. First of all, there is a network supported layer. There's a links, the 2 subgroups are there, the user support layers. Okay, in the network supported layer, first 3 layers are there. There's a physical, the bottom layer, the data link, the network. The transport layer will link between the sender and receiver. The session, presentation, and application, these three layers are used by the users. Both part of the users can use this. Okay, now that is the total layered architecture. So first of all, as you can see, there is device A and device B. So if they want to connect with each other, they will go through to the internet module, or intermediate nodes are there. Some routers, some modems, switches, relays are related to it. They will establish a connection between these two. But what will happen underneath? Okay, the main thing is that in a particular device, you have to keep on mind the first three layers are related to this. These three layers are related to the software part of the device, whether it is laptop, that is a tablet, or personal computers. In both parts, the device to, if it's a receiver end, so receiver section and sender section will, these four layers or three layers will be same. Okay, till fourth layer. Okay, till fourth layer, from the seventh layer till fourth layer downwards, that is same on the device section. Okay, in this device section there is the application layer, that means some application softwares are incorporated. Presentation layer will just make the data, make a frame. Session layer will set the session, that when we will start the communication between these two. Transport layer will create a link to make a network through to the server. Then it will go to the network part. Network part is the backbone part of the basic internet. So in the network part, it will establish the network in the server section. It will give an address and give some destination port and source port to identify where the data will came, where we should send the data. All informations are there. After that, the data link layer will establish the link between these two and make a session out of it. And the physical layer is the physical destination to connect both these things. That means you can use some transmission mediums. It may be antenna by electromagnetic wave, it may be optical fiber by light wave, it may be LAN or WAN, some connections, some connectivity. So it may be connectionless or it may be wired or connected. So the main basic or backbone of the network is in the physical layer, the transmission part, data link and network layer. After that, the transport layer and the session from the application layer, they are most probably on the software part on the devices. Okay, so that's the thing, that's the basic thing of the OSI layer. Now, why we use the layered architecture? Because it interfaces between layers. Each interface defines what information and services a layer must provide for the layer above it. The upper OSI layers are almost always implemented in software. Lower layers are a combination of hardware and software, except for a physical layer, which is mostly hardware. Now, there is an encapsulation process, that how the total thing is going to happen in the OSI model. As you can see, in the seventh layer, that is the application layer, you can see there is a header of H7 and D7 is a data unit, and after that it goes to the PPDU part. That means in the application layer moves from the layer to descending layer, sequential order, the application layer, and SPDU, another application layer, the session layer, that will set up the session. There is the presentation layer, that is the session layer, and also the segment packet will then start on the networking section. D4, the data is there, the H4 is the header of the packet, and the packet will in the transport layer, the total data is considered as a segment. In the network layer, it has been set to as packets or frames. After that, it will make a frame with a trailer part T2 and header part H2, and there is a bit stream right there, and it will transmit through in the same order from the physical layer to the application.